Okay, today we're going to learn continuous random variables and their probability distributions. So, which is chapter 15. Okay, we have chapter 15 for general continuous, and we have chapter 16 for normal. Okay, so have two chapters for continuous random variable. We have two chapters for discrete random variable before. Okay, chapter 13 and 14 is on discrete, and today is on continuous. Why I teach at the beginning of the probability section, I have explained what can be a discrete random variable and what can be a continuous random variable. So for a continuous random variable, it's normally a measurement amount. So the height of a person, the weight, or like the amount of water in the bottle, they all can become continuous random variable. Okay, so when a variable can measure any value within a particular interval, the variable is continuous. Okay, a continuous random variable can be described by a probability density function that displays the following property. Okay, first of all, this is not a distribution table anymore. I can't give a table anymore. It must be represented by a probability density function. Okay, this density function is not going to give you probability at individual points, at each point. Okay, it gives you, like, I'll explain more what will become a density function. So what is a density function? So the probability is represented by the area under the curve. Okay, the first condition is the area under the curve will be the probability between an amount. Okay, let's say I have random variable x. Okay, random variable x. And then we have density function fx. Density function fx. Okay, I want to know the value in between a and b, including a and b. Not including a and b. Including a, including b, not including a, but including a, not including b. They all have the same probability. So it doesn't matter whether you include a point or not including the endpoints. The probability is always become the area in between a and b. So if we have the random variable x, and we have the density function fx. Let's say the density function looks like that. In between a and b, say it's those 2 points. The probability x can take value in between a and b will be this area here. We find that area, and that will give me the probability in between those two values. Well, whether it's including those two values or not including both or include one of that, it doesn't matter. It always be the same probability. Okay, so that's the thing different from discrete and continuous. In discrete, let's say x smaller than 2 and x smaller or equals to than 2. It's different. Okay, the probability 2 will be include or not include. But in continuous, it doesn't matter. It can include the endpoint or doesn't include the endpoint. It will be the same amount. Okay, it will be the same probability. That's the first thing you need to know. Second, the probability of taking specific value is 0. Let's say, for example, probability x equals to 2. That will be 0. If x is a continuous random variable. I can't take specific values. I can't take x equals to something. I'm always talking about an inequality. Okay, must be an inequality. In between something, less than something, greater than something, that's all fine. But I can't say x equals to something. When you say equals to something, that will become 0. Why is 0? Because the area between the point will be 0. Okay, the area for 4 to 4, which is 0. There's no area, it's just a line. So the area will become 0. So that's explain why in question 1, in part 1, I can include or not include the endpoints. Because for the endpoints is 0. For that single point, it is 0. So it doesn't matter. Okay, it doesn't matter. And number 3, as the probability for every possible outcome of an experiment will be equals to 1, then the area under the probability density function is 1. For example, I have n points. Let's say I have n points C and D here. So the integral from C to D of fx must give you 1. So everything under the curve will be 1. The whole area under the curve must be 1. Okay? So it's same as you sum all the probability in the table and give you 1. It's the same reasoning here. Okay, very important thing here. To enable the area and a graph to be 1, continuous probability functions are usually represented by a hybrid function. Okay, why by hybrid function? Let's think about that. Y equals to x squared. For example, y equals to x squared. That's a density function. Okay, if your x can go negative infinity, your x can go positive infinity, think about what area you might have. Like the whole area under the curve. What's the area will become? Infinity. Okay, you have infinity high values. And you have infinity area. Like you can keep going forever that side. Keep going up. You will have infinity area. Okay, which is not going to be 1. So therefore, we will restrict this. Okay, we will restrict this. We can only talk about the density function when the area giving you 1. So let's have a think. If from this point, okay, from this point to this point, that area gives you 1. Okay, that area is 1. So we can only take from 0 to b, that is 1. So how about other points? I can only talk about 0 to b. Then other points will all become 0. The hybrid function will be, okay, I will describe this as x squared from 0 to b and 0 elsewhere. That's the way I describe a probability density function. So in between 0 and b, that is 1. Okay, that area is 1. But it is not enough. I only talk about 0 to b. How about other points? How about like all the rest values? There's infinite many values on the left and the right. Then I will say elsewhere is a 0. Okay, all other places, that is a 0 probability. There's no probability at anywhere else. So I will have a hybrid function. I will have a hybrid function. I'm not sure if you can remember at this point. I will do an example later as well. But you will be asked to sketch density function. You'll be asked to sketch density function. When you sketch your density function, you are not only sketch like the blue part, you also need to sketch the 0, even though it's on the x-axis. Okay, anywhere else is 0, so you need to label the 0, y equals to 0. So you need to draw a line on the x-axis. Okay, that is a full graph for density function. You need to show 0. If you only show the blue part, which you only show 0 to b, what's happening? Okay, how about other points? The other points is 0. You need to show the 0. How to show it? Sketch it. You really use the pen to sketch a line on the x-axis and make sure examiner can see it. Okay, make sure examiner can see it. I'm like quite sure you will be asked this type of questions because every year you'll be asked sketching density functions, and every year we'll have students not sketching the 0 points. Okay, so 0 needs to be sketched on the x-axis. I have emphasized about 3 times now. Make sure you remember that. We'll have questions later. Okay, we'll have questions later. You can see that similar type. Okay, so again, we need to check. As I said, only follow some conditions, then it can become a density function. Not all the fx can become a density function. Let's say just a normal x squared can't be the density function because the area under the curve add up is not 1, it's infinity. So we have conditions to check whether this is a probability mass function before. And we also have conditions to check whether this is a probability density function for continuous. We can check for discrete and we can check for continuous. We need to check whether this is a continuous function or not. Okay, by what? Two things as well. One thing is you need to make sure all the fx is above or equals to 0. So everything on your graph can't be below the 0, can't below the x-axis. Why? If you have a part of graph below the x-axis, you will achieve a negative area, which means you have a negative probability, which is not true. Okay, you can't have any part of the graph below the x-axis. If it's below the x-axis, you will have negative values, you have negative areas, and you won't have negative probability for sure. So it's not true. So first one, you need to sketch or use some way to show that all the thing is above the x-axis, which then satisfy condition number 1. Okay, condition number 2. You want to integral the thing. Okay, you want to integral this and to show that get area of 1. To get area of 1. Okay, be aware of that. The notation I have here is positive infinity and negative infinity here, but it's not going to be negative infinity to positive infinity. Why it's not going to be that? Let's just use the example above to show number 2. In this one, what I need to write is negative infinity to 0. I will integral the line 0 dx plus, and I will have 0 to b dx, and I will have 0 to infinity 0 dx. In this part and this part, I don't have x squared. Actually, I have 0. It's 3 different functions. Okay, it's hybrid function. I'm not going to use negative infinity to positive infinity to integral x squared. I will do part by part. Okay, 0 to negative infinity to 0, integral that. 0 to b, integral once. B to infinity, integral once. But in your actual paper, I will say only write this is enough. Okay, only have that is enough because you know that all the other parts will have an area of 0. So only 0 to b. So be careful that's not negative infinity to positive infinity on this single function. It's like with proper domain. Okay, it's the proper domain you have. It has been provided in the question. It's not going to be everything. Okay, if you have everything, you're not going to have 1. You have infinite areas. Okay, you have infinite areas. So still 2 conditions to check. Okay, 2 conditions to check. Okay, it's hard to explain the theory by, or let's have a look at some examples here. Okay, question 1. A. Show that fx is a probability density function of a random variable x. Okay, I need to show this is a probability density function. Okay, how I can show that? First, I will sketch for it. Number 1, I need to sketch for this graph. If I'm going to sketch for this, I'll have x-intercept at 0, I will have x-intercept at 2. And I have a turning point at 1, 3 on 4. And other part get 0 and 0. Can you see the black line? I need to sketch for it. Can you see the black line? I need to sketch for it. That's a density function. That's a full graph for density function. If you only show the red part, which is not correct, okay, you must have the 2 lines, the black lines, okay, which at 0. So first one is satisfied. Okay, fx is greater or equals to 0 for all x as shown above. That's my first thing I need to show. Everything needs to be greater than 0. Okay, everything needs to be greater or equals to 0. Second, I need to show the area equals to 1. So 0 to 2. Okay, minus 3 on 4x squared plus 3 on 2x dx. Minus 1 on 4x cubed plus 3 on 4x squared, 0 to 2. Okay, minus a quarter times 8 plus 3 over 4 times 4, that's a minus 2 plus 3, which equals to 1. So that is a probability density function. The area under the whole thing is 1. Okay, the area under the whole thing is 1, which means all the probability adding together will be 1. And that's correct. Okay, and that's correct. So this can become a probability density function. Okay, this can become a probability density function. B is asking finding this correct to 2 decimal places. If it's correct to 2 decimal places, I need to use calculator to do that. But have a look. We have, this should be a capital X. Okay. So X is less than 1.5. Okay, X is less than 1.5. Have a think. Less than 1.5. What's the smallest value you can take? 0. You are not going to write negative infinity, okay? You're not going to write negative infinity. So smallest number is 0. I will have 0 to 1.5 of fx dx. I'll use my calculator. Okay, I have a lot of students write this wrong. Okay, some of them write like negative infinity is 0, some write negative 1 to infinity is negative 1 to 0 to 1.5, which is incorrect. You need to be aware of like what is the smallest domain you have. I will just finish write this. So you have this one. This one you can just have 0.3 to 1.8. Oh, sorry, I need to label the points here. 2, 0 and 0, 0. So 0.3 and 1.8 is always in the domain. Which is good. Okay, which is good. Better not to write like, okay, sorry, better not to write fx here. Trying to write this. You're trying to write the actual function you want to do, because fx is a hybrid function, except it have a function there and have a 0 here. Okay, so it represents 2 things. So do not use fx. Trying to use the function itself. How about this one? This one is the intersection between that and that over the probability x less than or equals to 1.5. So that will gives you 0.75 to 1.5, which is all good for that function here. And divide by 0 to 1.5. Of that here. Well, you can do it by hand, but like it asks for 2 decimal places, so it's a CAS question. I can directly just use calculator to do that. I will define I'll define this function here. Okay, define the function here. Okay, the first one, asking for 0 to 1.5 of this function fx, and I want to define that value. Okay, that's 0.843. That's 0.84. Be aware of that, like your value must be less than 1. Okay, if anytime you just do something wrong and get a value greater than 1, you need to be aware of that. You see like there's something wrong. Do not just copy down whatever from your calculator. You may have problems. Okay, you may find some problems. Or say if your domain, you give your domain wrong. If you give your domain wrong and you can go over than the domain and you have area greater than 1, and you will realize, okay, I may do something wrong here, and then you need to go back to check. So what we have here, I will just copy that thing down, and I have 0.3 and 1.8, 0.91, 0.91. Okay, the last one. The last one is a fraction. So I'll copy this one to the bottom, and I'll copy that one down as well. That's a 0.75 to 1.5, I remember, and then divide by 0 to 1.5. I have 0.625. Well, I'll leave it exact. Okay, I'll leave it exact. It will be 0.25. 625 is the exact value. Okay, it's the exact value. I'm not sure if you know this. I really don't want to say this, but like I think it's better to explain here. There's a difference between rounding and correct to how many decimal places. That's two different things. Okay, that's two different things. If you go rounding, round to 2 decimal, you must have 2 decimal places. Okay, your answer must be in 2 decimal places. If it says correct 2 decimal places, which means you can have 2 or more decimal places. Okay, 2 or more decimal places. So you can have 3, you can have 4. The answer is all correct. As long as the second place is correct. Okay, as long as the second place is correct. But there is something called like double rounding errors. Okay, double rounding errors. For example, I have that. A number like that. Okay, correct to 2dp. The second decimal must be a 3 because the next digit, the actual size of that, the next digit is not going to round it up. So I should see your second decimal places be a 3. But some of you may want to correct it to 3 decimal places. Then when you correct to 3 decimal places, the number become that. Okay, the number become that. And then when I try to round from your answer here, the next digit will be a 4. Okay? Then it's double rounding error. That's wrong. Okay, that answer is wrong. So in most of the case, if you say correct to 2 decimal places and you give more, most of the time it's correct. Only when the next digit is a 4 and the next one trying to round it up, then will become a double rounding error. Because when you answer this answer to me, okay, I will try to round from your answer and I will round it to 0.74, and it's a double rounding error, which means your answer will be wrong in this case. Okay, so the point I want to say here is trying to make 2 decimal places. If asked for 2 decimals, just give 2 decimals and can make sure that's a correct number. Okay, that's a correct number. But like as I said, I must let you know there's a difference between rounding and correct 2. Okay, rounding and correct 2. That's why I answer this question, I can give 0.625. Because if I correct to 2 decimal places, that's still correct. Okay, that's still correct. And it's an exact number. Plus is an exact number. And I prefer exact number. I can leave my answer like that. There's nothing wrong with it. Even though it says correct to 2 decimals, I answer 3. And it's also a correct number. Okay, rounding and correct 2 are 2 different things. Rounding must be definitely 2 decimal places. But correct 2 can have 2 or more decimals. As long as when I round your answer give me the same as what I'm rounding to 2 decimals. Okay, so that's the difference. I was just struggling to say whether I should tell you this or not, because like when you know this, you start to round there like really random things, like you're like 3 decimal, 4 decimal, oh I can leave more, good. But do not do that. Okay, when you see it correct to 2 decimals, give 2 decimals. Okay, that's the most safe way to do it. The next one say correct to 2 decimal places. Find the value a such that x greater than a will give you a quarter. So what I should have is integral greater than a, the lowest value is a, but you have an upper boundary at 2. And I want this value to be a quarter. Okay, I have a to 2. Can't have a to infinity. If you have a to infinity, then you can't solve for it. Okay, so it's a to 2. Then I can solve it by calculator. Menu 3, 1. I want to solve for this. Okay, a to 2 dx. And that equals to 0.25. Comma a. I'm solving for a. Okay, a to 2fx, and that equals to a quarter. I'm solving for a. Then you have these answers, and you need to choose the correct one. That a must be in between 0 to 2. Okay, that a must be in between 0 to 2. Or you can even directly restrict it at the top. Okay, directly restrict it. But I have this one, 1.34. All the rest is out of the domain. So I have 1.35. Okay, 1.35. All right, next one. Okay, next one. Find the value of k if the following is a probability density function. Okay, I'll do one example here and you'll do the rest. Okay, find the value of k. Each of the following is a probability density function. So first of all, when you have this type, just forget about the all above 0, 1, like forget the first one, you directly start from the second rule, okay, the second one. Because the crucial thing is the every end of the curve must be 1, in between 7 to 17. Then you will think about, okay, integral, this k can put outside, sine pi 10x minus 7 dx, in between 7 to 17, and I need that to be 1. Okay, I need that to be 1. So the integral for that will become 10 on pi cosine, negative 10 on pi cosine pi over 10 x minus 7 to 17, and that equals to 1. That's minus 10k over pi cosine that 7 to 17, and this 1. And now I can evaluate that. If I put a 17 in, that's a 10, that's a cosine pi. Minus, I put a 7 in, that's a cosine 0. Cosine pi is negative 1, cosine 0 is a 1. So inside is a minus 2. Okay, inside is a minus 2. So 20 pi k equals to 1, k equals to pi on 20. Just trying to solve for it. If you want to solve for some value, given that is a density function already, then you just need to start from number 2, okay? Start from condition 2 to make the area to be 1. And the value solved out should be the correct answer. Okay, should be the correct answer. Unless you solve out 2 values, and you need to sub in each to check which one can make the whole graph above the x-axis. Okay, unless you solve out 2. Because if that's the only answer, you don't have anything else. If it want to become a density function, they must satisfy everything above the x-axis. No point for checking. But if you have 2, you need to see which one actually gives me an area all above the x-axis. Okay, for B, I have this graph. What I will have is k pi integral 1 over 1 plus x squared dx from 0 to 1 equals to 1. Okay, this will become a CAS question. Okay, I'll say just a over pi times integral 0 to 1 over 1 plus x squared dx equals to 1, comma for a equals to 4. Okay, a equals to 4. Directly use test to solve for that. Well, if you learn Spec, you should know that is a tangent inverse. Okay, that's a tangent negative 1 and 0 to 1, and that should be 1. Okay, k over pi. Tangent inverse 1 is pi on 4. Tangent 0 is 0. That's 1. And k over 4 equals to 1. K must be 4. Okay, Spec students need to know how to solve it by hand, but method students can solve it by calculator only. Okay, just by calculator. Alright, the rest of the time I want you to finish page 4 for me. Okay, finish page 4 for me. There are 2 questions on page 4. Same idea, you need to do that before next lesson. Okay, before next lesson. I'm not going to teach those 2 pages on the class. I'll give you the answer next lesson and you need to check for it. Okay, so the rest of time you will do this page.